atom. Smallest identifiable piece of matter. Somebody for the first piece candidate, somebody tell me. What happens to take an atom, you split it in half? What happens, Alex?
Isn't it nuclear fusion or something?
Fusion we putting together. What's the other one?
Rips apart.
Rips apart. It's fission, right? Okay, so what happens if we take an atom and split it?
It gets explosive.
It's explosive, atomic bomb. Fantastic. And what's the other application, Lily? Splitting atoms. Atomic bombs and? The safe version we kind of like.
Why am I forgetting the last?
Hudson, you know?
Nuclear energy.
Nuclear energy,
Yeah.
nuclear power plants. Fantastic. So, what we're not going to do is we're not going to look at what's underneath an atom. We're not going to open up that car hood. Instead, we're going to look at an atom and say, this has a distinguishable characteristic, and that is what calls it an element, and that's what we're getting into, okay? So, brand new stuff is element. Now, you probably did this in middle school, but we're going to put a very specific definition, high school version, all right? And that is an atom with an individual identifiable characteristic, all right? So like sodium, all right? Most people know sodium chloride's table salt, right? Good there? However, if I have a hunk of sodium, just chunk of raw sodium, and I throw it in water, it explodes. There you go. Take sodium, throw it in water, it explodes. If I take chlorine, which is the other half of sodium chloride, table salt, if I breathe that in, you die, or you at least have really, really bad lung problems for a couple of years. So the stuff that makes your food taste good is made half out of something that explodes when you put it in water, half out of something if you breathe it in, it's dangerous. However, when we chemically combine the two, it makes your food taste good. It's also the same thing. Sodium and chlorine is also the reason your muscles work. That works off of a sodium chlorine signal, which is why after you go in for your weigh-in, what do people drink?
Water.
And what's like the number one thing wrestlers tend to drink right after weigh-in?
Usually we drink water.
And there's like the number one thing most wrestlers do.
Sometimes we eat and then we drink Gatorade.
Gatorade, which has got salt in it, electrolytes that cause your muscles to work. Sodium is an electrolyte.
I don't drink anything personally. Just preference.
Okay. Alex, you have a question? Or are you just saying? Okay. What else we got? We got carbon. Carbon is an identifiable characteristic. If you take carbon, you get a charcoal briquette, put under some heat and pressure. All right, you get graphite, which is your pencil lead. Your pencil lead is made up of mostly carbon, just carbon. However, if you put it under more heat and pressure, what does it make? I'm just testing to see what your middle school science teacher told you. Yeah.
Diamond.
Makes a diamond. So, depending upon how you arrange those carbon atoms, you can either have charcoal briquettes for your grill, you can have graphite for your pencil, or if you do enough, you can have diamond, all right, for your rings, your tools, all right. I'll never make you memorize what these are, so the point of elements is to understand how to use the periodic table. So if you look behind Caden, we got the periodic table of elements, all right. That thing is already out of date. Most periodic table of elements are out of date because most of the things on the bottom row have been discovered. So that thing is still being added to year over year. That whole bottom row is already finished out. It goes all the way to the right. Right? So where those gaps are at in that bottom row, right, we have already discovered those elements. So chemistry is still a thing where we're discovering how things work. Which is a weird thing to think that we're teaching something that is still being perfected on. All right? All right. Now let's take those atoms, those individual atoms of two different elements, and we combine them together. We make a compound. Now, when it comes to other classes, there's a specific definition for a compound, a specific definition for a molecule. I'm not going to beat you to death with those semantics. I'm going to call them the same thing. All right? At least for right now. So if we take two different elements, smash them together, all right? They're chemically bonded together, you create a molecule or a compound. One up top right. What's that one?
Water.
Water. What's the true name of water?
H2O.
H2O. What's the true name of water?
Hydrogen monoxide.
Dihydrogen monoxide. When I was in high school, there was this big Facebook scare of dihydrogen monoxide and how they used to serve it in schools. Did you know if you breathe in dihydrogen monoxide, you die? Did you know they serve dihydrogen monoxide to kids in school without supervision? That was this big whole scare. All right. So, what we're going to learn is some of the science of how it's, and understand what it is and what it's truly saying.
Okay, well, wait. If you think about it, if you just use the scientific name, if you breathe in water and it gets in your lungs, you're gonna die.
Yes.
That's drowning.
But Facebook moms were literally thinking dihydrogen monoxide was something that is actually inherently dangerous.
A farm came out and said they didn't use the dihydrogen monoxide on their crops.
So, you just gotta learn how to do this. Talk about the science. They were trying to ban. I guess they didn't tell you. They were trying to ban dihydrogen monoxide in schools. That was a legit thing. I'll pull it up later. All right. Now, if I take some of those same elements and I rearrange them, all right, we can make sucrose. So, if I've got hydrogen and oxygen, makes water. If I throw in carbon and arrange it a certain way, we take water, and then now we have sugar. So what I want you to kind of understand is that the majority of whatever's found in our universe is made up of mostly the first 10 elements on the periodic table. Almost everywhere you're going to see hydrogen. Anything that's living or breathing has carbon in it. And so what chemistry kind of looks at is not just what the atoms and the elements are, but how they arrange to change what's going on. And the last one down here. What's that one? TNT, which stands for trinitrotoluene. That's the true name of TNT. Dynamite. So, we start off with oxygen and hydrogen. We have water. We add carbon to it and arrange it a certain way. We create sugar, which provides us to have life. Your body needs sugar to produce energy. And then if I add nitrogen to it and change the arrangement, you create something that's explosive. I don't know about you, but I find it crazy that the ingredients to make an explosive thing and the ingredients to make sugar are very close. All right. So that's what compound molecules are. This picture I really recommend you draw, okay? This is how we're going to break apart our vocab when it comes to this stuff. All right, I'll give you a second for that. This picture does a pretty good job of explaining why I'm not going to differentiate or do semantics on when is it a compound and when is it a molecule. Because all compounds are molecules, but not all molecules are compounds. All right? It depends upon what is it specifically. So I'm going to work from left to right. If we take a pure substance, something that is just pure, there's nothing else mixed in, and it is one element, like neon. Neon loves to not touch anything. It's about as antisocial as you can get. It doesn't like to react with anything. It just wants to hang out with itself. It won't even hang out with other neon atoms. They just bounce off each other and say, no, I'm good. All right. About as non-reactive as you can get. However, the moment an element can turn into a molecule is when you look at something different like oxygen. Oxygen loves to be bonded to itself and create O2. All right. Yes, there's O3, and then there's just O floating down there, but that's not very common, and we really don't talk about it. Part of the ozone layer is built off of O3 molecules. All right, but the oxygen you breathe is just O2. So when is it considered a molecule? Is when two atoms are combined together. When is it technically considered a compound is when two different elements are combined together. All right, and that's what water is, H2O. 2 parts hydrogen, 1 part oxygen, bonded together, all floating around. What we don't talk about, we want to unpack right now, is ions and ionic bonding, because those look a little bit different. Ions are what make crystal structures, so geodes. If you ever had a hunk of salt that kind of grows in a crystalline form. Okay. What you're going to be doing this week is we're going to go through a couple different examples of molecules, and then you're going to make a molecule. So I got a whole list for you. TNT's on that list, sugar's on that list. What you're going to do is you're going to create either a poster or a 3D model, all right, and then give me some information about that molecule. If you make a 3D molecule using some of the equipment I have or some of the modeling kits I have, or make one on your own with some stuff you got at home, I'm probably going to hang them from the ceiling. Because 1, I think they look cool, and 2, I could like more stuff in this room. All right, we good here? Questions, comments, concerns? Moving on. Hudson is bored out of his mind. You ready, Hudson?
Yeah.
Question for the day. Did you already get candy? No, Alex got candy. Did you get candy yet?
No.
Okay. Hudson, help me out. Picture on the left. It's oxygen. We already talked about it. How many atoms are in the picture? 6 atoms. How many molecules?
3.
3. Fantastic. All right. That's what I want you to be able to pick out of this. If it's all one color, you know it's all the same element. Tell me how many atoms and molecules there are. Ready? Can I try behind the back?
Sure.
Okay. Oh, almost. I just didn't want to hit Alex, so I want to make sure I went over. Next one right here. This is propane. So the stuff that comes out of the gas jets in the back is propane. Knowing what you know. You ready, Lauren? Knowing what you know. How many different elements are in that picture?
In the propane?
Yeah.
2.
2 elements, fantastic, because they're color coded. All right, the black one's carbon, and the white ones are hydrogen. And could you count how many you have of each?
There's 8 white ones and 3 black ones.
Fantastic. We have 3 carbon molecules. Sorry, 3 carbon atoms, and then 8 hydrogen atoms. So where does propane get its name from? Well, the prefix prop, meth, prop. Prop means 3. That's 3 carbons. All right. We already talked about water. Let's talk about the one on the right.
That's DNA.
That's DNA. How many molecules is DNA?
20.
You're thinking about proteins. You're thinking about amino acids. Yeah.
It's 2, isn't it?
It's a lot more than 2.
Yeah.
Is that 4?
It's made of 4 base pairs, absolutely. But 1 DNA strand, all chemically bonded together. Alex?
Is it 1?
It's 1. It's 1 molecule. So what you do is you got tons of atoms. When they're chemically bonded together, it makes a molecule. I don't care how long that molecule is, but if it continues on forever and it's all chemically bonded to each other, like DNA is, all right, then you have 1 molecule. All right, now, is DNA ever truly in just 1 strand? Absolutely not. There's RNA and there's proteins flying off, and all right. But if we just look at 1 strand of DNA, all right, it's all considered 1 molecule. All right, we already talked about sugar. We already talked about TNT, or trinitrotoluene. All right, what I want you to be able to do, essentially, is understand if it's chemically bonded together. We don't know how yet. We know it's a molecule. We're able to tell how many elements are in there and how many atoms. Okay? Yeah.
Will we get to know how it's chemically bonded?
Yeah, we'll get there. This is chemistry. We'll definitely get there. We'll talk about chemical bonds probably in about 4 weeks. All right, I'll overwatch this video at the end because since I'm recording and I can't show this video because I didn't make money off of it, but I'll show it at the end. Okay, so let's change gears a little bit. All right, let's look at mixtures. So we can't really see atoms, elements, or compounds. What we can do is we can see mixtures. And this is, I've heard it pronounced homogeneous, and I've also heard it pronounced homogeneous. I really don't care. Homogeneous is if you enunciate every single syllable, or homogeneous. I've heard both, don't really care. Right? But I'll use them interchangeably. So homogeneous mixtures, right, have an even distribution of whatever is inside of it. It could be atoms, molecules, compounds, doesn't matter. As long as it is two different things, could be atoms, elements, compounds, mixtures, whatever. Right? But you cannot see those individual layers. Miss, I skipped half a week to go show horses. Cows. Let's talk about cows. What's some of the stuff that's in milk?
Milk,
What's in milk? What's some of the ingredients for milk?
protein,
Protein. There's proteins in there. What's that? Calcium. Absolutely.
water,
Water.
milk.
There's milk and milk.
Sugar in there.
There's sugar.
Usually.
I'll put a piece of candy on it. I mean, if you want it, you can tell me what kind of sugar it is. I know you know it, but maybe you haven't made that connection.
Natural sugar.
Mm-mm. And if somebody has a hard time drinking milk, they are
Lactose.
lactose intolerant. All right, means their body can't digest that lactose sugar. Right?
Imagine not being able to drink milk.
Sorry.
Jesus, you probably broke it.
It's a dum dum. You can still eat it. It's just in two pieces. All right. So, what is in milk? Well, there's proteins, there's water, there's fats, there's lactose. What else? I'm missing one.
Fiber.
Calcium. Not really fiber though. But there's all that stuff. Now, when you look at a glass of milk, can you see those individual things?
No.
Not really. Maybe if you let it settle and whatever. But you can't really individually see that stuff in a fresh glass of milk. So that's why it's considered a homogeneous mixture. Right? Most of the stuff we're going to make in this class is you're going to take a solid and dissolve it in a liquid. When you do that, you're going to create a homogeneous mixture. All right? Tea, sugar water, salt water, all those are considered homogeneous mixtures. What you're going to do, hopefully for this week, we're going to do a lab I've never done before, is you're going to make a mixture of different bubble solutions and seeing how that affects how easy it is to make a bubble. But we'll see. I've never done it before. You're my guinea pigs. All right. Am I good to move on?
Yep.
Going once. Elaine's still right, so I'm gonna hold that. You done? Okay. All right. Heterogeneous or heterogeneous mixtures would be the opposite. All right. There's an uneven mixture. So an easy one would be salad. Take a salad. It's got all the pieces mixed up, but you can still see those pieces. You can see the carrots, you can see the cabbage, the onions, the tomatoes, the whatever. All right. It is an uneven distribution. Snow globes will be close to what we do in chemistry class. All right, snow globes, when you mix them all up, those particles won't dissolve in that liquid. So that way, regardless of how hard you shake it, the snow will just mix up and then settle right back down. When we do stuff in this class, though, and we make a heterogeneous mixture, a heterogeneous mixture, we'll mix stuff up, but it won't actually mix like oil and water. Everybody knows you take oil and water and you shake it up. Won't actually mix, right? As far as what to expect on the quiz this Friday, expect more of the atoms and molecules and elements side and less of the mixture side. Because those atoms and molecules and elements are really important for what we're going to do next week. Right? Actually, just the rest of the semester in general. All right. I'll give you a second. Remember, notes are available on Schoology, okay? Am I protesting? Okay. All right. Black background. Remember, not write it down. So now explain to me, on the left side, what kind of mixture do you have and why? You already got candy. You've already got candy. You've already got candy. You already got candy. Brian.
Yeah.
I'm pick. There's only 9 of you. At some point, I'm calling you. All right. Which one do you want? The picture on the left or the picture on the right? None? Well, you get to pick, or I'll pick it for you.
You can pick.
Okay. Picture on the left. What kind of mixture is it?
M&M's.
What kind of mixture?
Something.
So on your piece of paper, you should have 2 types of mixtures written down.
Oh,
Which one is it?
the homo one.
It's the homogeneous
Yes.
or homogeneous?
Yeah, that one.
Why is that?
I don't know.
Well, homogeneous mixtures means you can't see the individual pieces. You can't see the individual
yeah,
parts.
it's hetero.
So why is it hetero?
Because you can see it.
You see the individual parts. What individual parts can you see? Either you answer the question, I'll pull it out of you. It's like the dentist visit. How hard do you want this to hurt?
To tell me the answer.
When you bite into the M&M, how many layers do you see?
One.
No.
You see?
Oh my god. There's
Your M&M mixture right here, Brian. You ready? M&M mixture right here. Do you see the individual colors?
Yeah.
Do you see the individual parts, individual pieces? Regardless of how hard I mix that together, will those M&Ms ever become to one giant M&M?
No.
No. So that's right. It's not. The reason it's not homogeneous is because regardless of how hard you mix this up, you will see its individual parts, its individual pieces. Okay. I feel like I should give you like a stale piece of candy for that one.
I answered.
You did.
After he's pulled it out of you.
Okay. All right. Picture on the right. Caden. Caden, don't laugh too hard. I'm coming for you next. Caden. Picture on the right.
Heterogeneous.
The picture on the right.
Yeah.
Can you see the individual layers?
no.
No.
No. What is Kool-Aid made of?
Sugar.
Sugar?
Kool-Aid.
Artificial.
I don't know.
Kool-Aid powder? And?
Water.
Fantastic. I want to let you know somebody from 3rd period legitimately straight face told me Kool-Aid's made out of powder, sugar, and flour. Okay? So, you're already doing better than they did 3rd period. So, help me figure it out. So, we have a glass of Kool-Aid right here. It's got sugar, water, and the color in it, right? What kind of mixture is it?
Heterogeneous.
Try again.
Homogeneous.
Homogeneous, because we're homogeneous. Homogeneous, so the prefix homo means to one. So, can you see the layers in here? No, you can't see layers in Kool-Aid, so it's a homogeneous mixture. We're getting there?
Yeah.
You get your giggles out?
Yeah.
Okay. Elena,
Give
Time
him
for
a
you
half
next.
stale piece of candy.
you ready? Okay, you ready?
Odo. Oh. Odo system.
Which one do you want? You get to pick.
The blue one.
The blue one, alright. You got the blue one right here.
Okay.
All right. Now, I know you can't really quite see on this picture, but all of it's blue. We're going to call all of it blue in the picture, okay? What kind of mixture is it? Say the whole word.
Homogeneous.
Homogeneous or homogeneous, all right? Homogeneous mixture, why is that?
Because there's not one.
There's not more than one layer. It's 2 different things. Whatever this solution is made out of is probably 2 different things and not just clear water. Cool. There we go. That was easier. All right. Who am I going for next? I think I'm going to go for Skipper over here. All right, Skipper.
I don't like some.
Left side.
I'll take it.
It'll give you a different one.
Hey, you can hold on to it. You can switch out the flavors later.
No,
Okay.
you can't do
No, I
that.
don't
You
like
gotta
sour
go.
cream.
I got Jolly Ranchers and Dum Dums too. Or sorry, not Dum Dums, Smarties. Yes. Yeah, we can get you Smarties. Just hold on to it. Okay. Stop. Are you ready? On the left side. You said heterogeneous? Fantastic. And why is that? Fantastic. Whew. Man, it's getting better. First one felt like a horror movie, and the last one felt a whole lot better. Fantastic. All right, what we won't get into this class are colloids, which are suspensions, but hand sanitizer is typically a suspension. Those air bubbles in there, over a long period of time, would float to the top, but they don't really, so it's a colloid. We just won't talk about that when it comes to this class. All right. However, we're going to call that done for notes for today, and we're going to watch a video about the 5 most dangerous chemicals known to man. All right. Any questions about what we've done so far?
I want to ingest those chemicals.
I don't think you can.
That would be a bad
Well,
idea.
you was so good at that recording, and now I can't use it.
Poggers.
Cut it